So last class what we did is we were working with your translating, and we just practiced that because that is what I find to be the most difficult part of word problems for a lot of people, is translating from the words into our equation. So now we're going to go that one step further. We're going to actually solve our equations. So going through quickly, when doing a word problem, you want to first read the problem carefully. And I tell you to read it carefully because a lot of times what happens is they make some very subtle differences within the problem. What I mean is they'll be talking about yards in the first part of the problem, then the second part of the problem they change it to feet. So you've got to make sure you're paying attention and you see what those little changes are. So you got to make sure you read it carefully. Next thing is you need to represent the unknown by a letter. So that means your let statement. You need to write your let statements.
Oh, I have a question.
Yes, I have an answer.
When is your guys' grade book thing closing? Like, say, I have 5 weeks.
So after you write your let statements, you have to translate, meaning you have to write your equation so that we can go ahead and solve it. So then you solve it and you find your solution set. We call it a solution set because sometimes you're looking for 2 numbers, sometimes you're looking for 1 number, sometimes you're finding the lengths of the sides of a rectangle, so you need to make sure you have all your answers. You need to check each element in the words of the problem, make sure it makes sense. If we're trying to find an integer and I get a decimal, that's not going to make sense, so I have to go back and check something. If we're dealing with the length of a side and I get a negative, you can't have a negative length of a side, so you have to go back and check something. And then you always need to write your answer in the form of a sentence. And then you always got to keep track of your rounding. A lot of times, especially with money, they won't tell you where to round to, so you got to remember it's to the nearest hundredth or the nearest cent, as they like to say. So let's take a look at our examples. The only way we're going to get this is if we keep practicing them. So if 5 times a number is decreased by 12, the difference is 9, what is the number? Okay. So what are we trying to find? The number. So that's what our let statement is going to be. I'm going to say let x equal the number. So there's our first part. We have our let statement. Let's see. So once we get our let statement, we then have to go through and write our equation. So they told us 5 times a number. So what would that look like?
X times 5.
Which would be 5x. Yep, x times 5, 5x. Decreased by 12. So minus 12. The difference is, that means equals 9. So 5x minus 12 equals 9 would be our sentence, our equation. So you guys know how to solve these. You did really well with these last unit. Let's have you go ahead and solve it. So we got to add our 12. So when I add my 12, I get 5x equals a 21. Divide by 5, what does x equal? 4.2. So then I just kind of have to go back up here and check. They just simply told us to find the number. So it's okay that we got a decimal. If it told me to find the integer, I wouldn't be able to have a decimal. That answer wouldn't work. But they told us just to find the number, so we're good. So we just have to write our sentence. The number is 4.2. If they give you the problem in words, you have to answer it in words. So you got to make sure you include a sentence. All right, let's take a look at the second one. The larger of 2 numbers is 6 more than twice the smaller. Their sum is 27. Find the numbers. So this time we are finding the numbers. But how many numbers are we finding? 2. So that means I need 2 let statements. I'm trying to find 2 numbers. I need to have 2 let statements for each one of them. So it tells me the larger of 2 numbers is 6 more than twice the smaller. The smaller one is mentioned last, so that is your x. Whichever one they mention last is always your x. So I'm going to say let x equal the smaller number. So then the larger one is 6 more than, bless you. So where would my 6 go for 6 more than? After the subtraction. 6 more than twice the smaller. So what does twice mean we're doing? Yeah, multiplying times 2, which would give us 2x. So 2x plus 6 is the larger number. So there's our 2 let statements. In all of your word problems, you are always going to have something that is just x. X is always going to be there. So for our equation, they told us their sum is 27. Sum means we do what? Add. So my smaller number, which is x, plus my larger number is 27. So x plus 2x plus 6 equals 27. So let's have you go ahead and solve that one. Did you guys get x equals 7? Woo! All right. Oh, because you didn't subtract. No, you added 6. You need to subtract 6. So if x equals 7, that means my smaller number is 7. I got one of them. I got to figure out my larger number. So I want to plug 7 into this expression we had up here. So 2 times 7 plus 6. What does that give us for our other number? 20. So we just need a sentence. The numbers are 7 and 20. You don't need a very long sentence for your answers. Just state what the answer is. All right. Let's try our 3 on the back. So we got Rachel and Siobhan belong to different local gyms. Rachel pays $35 per month and a one-time registration fee of $15. And Siobhan pays only $25 per month but had a registration fee of $75. After how many months will Rachel and Siobhan have spent the same amount on their gym memberships? Lots of words in this one compared to the other ones. But ultimately, what are we trying to find? Does anybody know? Nope. We're trying to find how many months. So we're going to say let m equal number of months. So they gave us 2 different things. They gave us what Rachel pays. They gave us what Siobhan pays. So Rachel pays how much per month? $35. So she pays $35 per month. So 35M plus, how much was your registration fee? 15. So she pays $35 plus 15. What does her friend pay? Colons. So Siobhan pays how much per month? 25 with a registration fee of 75. So they want to know when they would have spent the same amount of money on their gym memberships. So what do you think I need to do with these 2 expressions here? We're looking for when they spent the same amount. Another word for same would be equal. So what should I do with these? Set them equal to each other. We're looking for when they're equal. They're the same amount when they're equal. So go ahead, solve for m. You got to get your m's together. M? M equals 6. So we just have to say after 6 months, they will have spent the same amount. All right, number 4. The number of children's tickets sold to Comic Carnival exceeded 3 times the number of adult tickets by 10. If the total number of tickets sold was 130, how many of each kind were sold? So we have 2 kinds of tickets we're talking about here. Children's tickets and adults tickets. So we need 2 let statements. So if we read through that first sentence, which one is mentioned last, children's or adult? Adults. There's our X. So let X equal number of adult tickets. So now we just have to figure out what the children's tickets are. It says it exceeded 3 times the number of adults. So what would 3 times the number of adults look like? 3x. Exceeds means we add. So it's going to be plus what? Plus 10. And that's your number of children's tickets. Alright, so we need to set up our equation now. They told us the total number of tickets sold was 130. So that means our adults, which is our X, plus our children's equals 130. So X plus 3X plus 10 equals 130. So again, let's have you go ahead and solve for X on that one. So what do we get? X equals what? 30. So our adults tickets means they sold 30 adults tickets. How many children's tickets did they sell? Yeah. Got to go 3 times 30 plus 10. So they sold 100. So we just need to write our sentence. They sold 30 adults tickets. And 100 children's tickets. All right, taking a look at our last one. We have Emily has $1.45 of change in her pocket. She has 1 more dime than nickels, and she has 1 less quarter than nickels. Write an expression or an equation that could be used to algebraically determine the number of coins in her pocket. Then solve the equation and state how many of each coin she has. So we have 3 different coins that we're talking about here. So we need 3 different let statements. Now, as I said, every word problem always has something that is just X. So which one is our X? Dimes, nickels, or quarters? Nickels. Nickels is mentioned last. So X is your number of nickels. So it says she has 1 more dime than nickels. So what would our dimes be if she has 1 more? X plus 1. And then she has 1 less quarter than nickels. X minus 1. There we go. There's our let statement. So now we have to set up our equation. And since they told us she has $1.45 in her pocket, that's what our equation is going to be equal to, is her $1.45. So what we have to keep in mind when we set up our equation is how much each coin is worth. Like a nickel is worth how much? 5 cents. But when we write that, it's 0.05x. So 0.05 times the number of nickels, so 0.05x. Dimes are worth how much? Yep, so 0.10 times our x plus 1. And then quarters are worth 25 cents. So it would be 0.25 times x minus 1. So then we just need to solve. So let's have you take a minute, go ahead and solve that. So we should get x equals 4. So if x is 4, that means Emily has 4 nickels. Dimes were x plus 1, so 4 plus 1 means she has how many dimes?
5.
Yep, so 5 dimes. And how many quarters? 3 quarters. Those ones are tricky, but you've got to just take your time and work through it.